Howdy, and thank you for viewing my Tech Talk. I am Dr. Amanda Lampton, and I am a Principal Research Engineer at Systems Technology, Inc., and the technical lead for this SBIR Phase 2 effort. Today, I'll give you a glimpse into our exciting technology that enables the characterization and prediction of test pilot-assigned levels of handling qualities and ratings. But before I dive into that, let me tell you about Systems Technology, Inc., or STI for short. STI is a small company with technical expertise in vehicle dynamics and control, flying qualities, piloted simulation, flight test, and human factors. It was established in 1957 by two giants in dynamics and control, Dwayne McCruer and Irv Ashkenas. We are a 100% employee-owned business with offices, lab, and product assembly space in Hawthorne, California. We have significant past work for the Navy, including design audits, control design, and algorithm development for aircraft such as the C-2A, FA-18, CH-53K, and MV-22. We also won the Tibbetts Award in 2012 for our parachute training simulator, Parasim. Now, back to the technology. The U.S. Navy set forth a challenge in the 2019 SBIR solicitation seeking test-enabling technology for the purposes of handling qualities evaluation and tuning in both simulator and flight test environments. The Navy envisions a sensor suite and software package that can measure physiological response to pilot workload and correlate it to handling qualities. The expectations for this system include near real-time measurement of pilot workload, deployable in both piloted simulation and flight test settings, simple to incorporate into handling qualities tests, compatible with aircraft gear and environment, and either self-powered or use instrumentation power. The transition target is the V-22 Osprey under the purview of PMA 275, as well as the various DoD flight test centers. Now you may ask, why? Why should we care about characterizing and predicting handling qualities? What is the operational need? What could be improved? Well, self-assessed pilot workload is qualitative but highly dependent upon the pilot, task, conditions, etc. In 1969, George Cooper of NASA Ames and Robert Harper of Calspan Corporation published their seminal report on the use of pilot ratings in aircraft handling qualities evaluations that produced the pilot rating scale that is still in use today. While several processes have been developed for pilots to rate workloads, such as Bedford workload and NASA TLX, a quantitative correlation between workload and handling qualities ratings remains elusive. Test-enabling technology is needed that allows quantitative measurement of pilot workload via physiological characteristics in conjunction with software to synthesize this and other performance and system data for the purposes of handling qualities evaluation and tuning. Validated sensor and software suites will enhance the effectiveness and reduce costs associated with flight test verification of handling qualities for new and modified aircraft by limiting requirements for repeated evaluation sorties with multiple test pilots. Our solution is PASS, the Pilot Assessment Scaling System. PASS integrates a disparate mix of measures including task performance measures, pilot vehicle system measures, and physiological measures to better characterize and ultimately predict test pilot-assigned levels of handling qualities and ratings. Our development and testing plan for PASS is right on schedule. We are wrapping up our Phase 2 base program with algorithm execution, i.e. developing the process of reducing test data, applying machine learning algorithms, and building models for predicting levels of handling qualities and ratings. We anticipate Phase 2 option funding shortly after the conclusion of the base program. The Phase 2 option will include further algorithm refinement, piloted simulation, and/or flight testing, followed by software validation and consideration of fixed-wing aircraft. This option will be a significant step in the development of PASS. Now, allow me to reiterate PASS's key features. PASS blends disparate measures that impact pilot compensation and hence pilot ratings, including task performance measures, pilot vehicle system measures, and physiological measures to produce valid predictions of handling qualities. The physiological data is gathered via commercially available hardware and software, thus keeping the cost of additional sensors reasonable. Finally, the software toolbox builds upon the industry standard MATLAB and its toolboxes. The advantage of PASS as a solution include 125 years of corporate knowledge as well as its agnosticism to aircraft platform. This means that the process integrated into the PASS software can be applied to any mission task element for any aircraft, fixed wing, rotary wing, etc., without significant deviation from the defined approach. What this brings to the evaluation of aircraft in the greater mission is enhanced effectiveness and reduced costs associated with flight test verification of handling qualities by limiting requirements for repeated evaluation sorties with multiple test pilots. We're in the final months of the Phase 2 base program of this SBIR program and are already looking toward transitioning this technology. In the base program, we conducted a piloted simulation test campaign with a generic helicopter model and 11 pilots flying 3 tasks. We will execute another test campaign, either piloted simulation or in a variable stability helicopter, and the option to continue the development of an exposure to PASS. Beyond Phase 2, we will cultivate continued interest from the primary topic endorser, PMA 275, and secondary topic endorser, PMA 261. We will also cultivate interest from those who expressed such, namely PMA 268 and PEO F35. We will also seek Phase 3 integration and flight test, as well as introduction of the technology to U.S. NTPS and Air Force TPS. The initial applications for PASS are the U.S. military aviation markets that develop and evaluate piloted aircraft. This market includes DoD flight test centers, for example, NAS Patuxent River and Edwards Air Force Base, military test pilot schools, and prime and Tier 2 aircraft manufacturers. Secondary markets will be identified from these same entities in U.S. allied countries. PASS will also find utility in the commercial marketplace where handling qualities assessments are an important part of the civilian certification process. Here, an emphasis will be placed on commercial transports, business jets, and the emerging urban air taxi market. The emerging product is the pilot assessment scaling system featuring machine learning-based algorithms that will be used to predict levels of handling qualities for both fixed and rotary wing aircraft. A validated PASS will enhance the effectiveness and reduce costs associated with flight test verification of handling qualities for new and modified aircraft by limiting requirements for repeated evaluation sorties with multiple test pilots. Thank you for listening to my Tech Talk. PASS is an exciting new technology that can benefit any aircraft platform, large or small, fixed wing or rotary wing. I ask you, dear viewer, to follow up with me to discuss your needs, or send me an email at alampton@systemstech.com, or send an email to our technical fellow, Dr. David Clyde, at dclyde@systemstech.com, and we can set up a time to chat. Thank you and have a fantastic day.